So this is our final project for class engineering 1035. So team members will be me, Deng, and the person filming this is Kwan. Alright, so background information on what are we doing. So we have created and wrote a program for a robot that can so basically autonomously operate on its own, stay within a set parameters, and will automatically reverse and move out of the way, which means that it will turn while reversing whenever it meets an obstacle in front of its ultrasonic sensor. And this robot mission will be finding a black square on the ground using a color sensor and stop in front of it. Okay, so this is our Simulink model. So we got the ultrasonic sensor over here. So we got the distance threshold. This is to determine if a object is too close to the robot or not. We got a color sensor, and we got a light threshold, which detects that helps the robot detects and helps the robot decide what value is black on its brain. We got a set speed, and also we got a touch button to start the robot. Just again for our calculation. We got the right motor goes to the right wheel, left motor goes to the left wheel, and we also decided to display the current state on our robot, which I will explain later on. Okay, so this is our function that goes. So this is like the brain of the robot. So we got our function. Our output would be right wheel, left wheel, and current state. It goes to the right motor, left motor, and the display on the robot. The input will be the ultrasonic sensor. We got a distance threshold, a light level, a light threshold, a set speed that we already put out, the button, and the gain. So we decided to double the value of our ultrasonic sensor and a color sensor. This is basically dividing that, saying that our robot have 3 Ks. So, and this code is just for the starting case is 0. So case 1, which is stopping in place, and if we press the button, it will give a value of 1. This will change the state into state 1. And in state 1, which is case 1, the speed is the amount of set speed that we already set out, and the desired rotation is 0 because we want it to go straight. And during this case, if the ultrasonic sensor detects an object in front of it which is smaller than a distance threshold, it will enter case 2. And if the color sensor detects a light threshold smaller than 12, which the number that we have calculated, less or equal than 12, the state would be equal to 3. And the button is just like a safety button for that we can turn off the robot.
For the case 2, you said the desired speed is negative set speed. So if the robot meet the obstacle, so the robot skills is gonna be back up. So we have the function desired rotation is light level minus light threshold time with gain. So if the US sensor greater than distance threshold 2 times, so state will be equal 1. So state equal 1, so it's going to be desired speed equal set speed, and desired rotation equal 0. Also, another case, if the light level smaller or equal light threshold state will equal 3, so the robot will stop.
Okay, so case 3, or light level smaller than equal than light threshold, basically means that if the robot has detected a black square or not. So, and then yeah, case 3 is, desired speed 0 and desired rotation is 0. And then this otherwise is basically conclude everything that if not of any of this condition is not met, then it will jump to this. So basically, if anything turns out wrong, then it will come to a stop, and state will be reset to a 0. And down here we got right wheel equal desired rotation plus desired speed, left wheel equal to desired speed minus desired rotation, which means that this is the reason why we put desired speed as 0, and then desired speed as set speed, and desired rotation will be 0, because for desired rotation, if the desired rotation is 0, then 0 plus set speed will be set speed, and then for the left wheel will be the same thing, set speed minus 0. So it'll come out the same. And the reason why we put plus and minus there, so it will be able to turn, because if you think about it, when a robot is turning, then it's basically one wheel is turning slower than the other one, or even back, or even in the opposite direction of another one. And then the current state equals state basically our way for displaying the case that we're on. For the Lego configuration, this is the robot that we use. We got the Lego EV3 Mindstorms. This is the platform that we use for our project. The equipment that was provided for us was ultrasonic sensor, which is the 2 eyes in front of it. You can see in the first picture. The touch sensor, which is a button. 2 battery powered motors. We attaches wheel to that, and a color sensor, which is the thing that is in front of the robot. Alright, and here's the video link that it showing that it works. Alright, so as you can see in the video, the robot keep detecting that it is too close to the wall or the parameters. It keep backing out and reversing, so it's gonna, and then when it comes back into case 1, it will go straight until it meets the wall again. Alright, thank you so much, and that is our final project.